Question 1. Which Azure storage account type is recommended for most scenarios, supporting all storage services? Blobs, files, queues, tables, disks, access tiers, and all redundancy options. Option A. Blob storage. Option B. File storage. Option C. General purpose V1, GPV1. Option D. General purpose V2, GPV2. The correct answer is General purpose V2, GPV2. Here's the explanation. General purpose V2, GPV2 is the recommended and most common storage account type, offering the latest features and optimal pricing across all storage services and options. Question 2. You need to store highly available data within a single Azure region that can withstand data center outages, but you don't require geo-redundancy. Which redundancy option should you choose? Option A. Locally redundant storage, LRS. Option B. Geo-redundant storage, GRS. Option C. Zone redundant storage, ZRS. Option D. Read Access Geo-Zone Redundant Storage, RA-GRS. The correct answer is Zone Redundant Storage, ZRS. Here's the explanation. Zone Redundant Storage, ZRS, replicates data synchronously across 3 Azure availability zones within the primary region, providing resilience against data center outages without replicating to a secondary region. Question 3. A company needs to store financial archives that are accessed very rarely, less than once every 6 months, but must be retained for regulatory compliance. Cost optimization for storage is a high priority, and retrieval latency of several hours is acceptable. Which blob access tier is most suitable for this data? Option A. Hot. Option B. Cool. Option C. Archive. Option D. Premium. The correct answer is Archive. Here's the explanation. The Archive access tier is optimized for rarely accessed data, stored for at least 180 days, with flexible latency requirements, hours, offering the lowest storage cost but highest access cost. Question 4. Which of the following is the fundamental difference in underlying hardware between a standard performance storage account and a premium performance storage account? Option A. Standard uses SSDs, while premium uses HDDs. Option B. Standard uses HDDs, while premium uses SSDs. Option C. Standard uses magnetic tape, while premium uses optical drives. Option D. Both use SSDs, but premium has more advanced caching. The correct answer is Standard uses HDDs, while premium uses SSDs. Here's the explanation. Standard performance tiers typically leverage hard disk drives, HDDs, for cost-effective storage, while premium performance tiers are built upon solid-state drives, SSDs, to deliver extremely low latency and high IOPS. Question 5. A company needs a cost-effective storage solution for archiving large volumes of rarely accessed historical data. Data retrieval can tolerate higher latency. Which performance tier is most appropriate for this use case? Option A. Premium blob storage account. Option B. Premium file storage account. Option C. Standard performance, general purpose version 2 account. Option D. Premium page blob storage account. The correct answer is Standard performance, general purpose version 2 account. Here's the explanation. Standard performance tiers, typically found in general purpose V2 accounts, are ideal for cost-sensitive workloads like backups and archives, where data is infrequently accessed and can tolerate higher latency. Premium tiers are significantly more expensive and designed for high-performance, low-latency workloads. Question 6. Which statement accurately describes the service support for premium performance storage account types? Option A. A premium blob storage account supports all Azure storage services including files, queues, and tables. Option B. Each premium storage account type is specialized and supports only its designated service, e.g., block blob storage for block blobs. Option C. Premium performance is only available for page blobs used by Azure VMs. Option D. Premium storage accounts automatically adjust to support any service based on demand. The correct answer is each premium storage account type is specialized and supports only its designated service, e.g., block blob storage for block blobs. Here's the explanation. Unlike standard general-purpose V2 accounts, premium storage account types are specialized. For example, a block blob storage account only supports block blobs, a file storage account only supports Azure files, and a page blob storage account only supports page blobs. They do not support other storage services within the same account. Question 7. What is the key difference in functionality between geo-redundant storage, GRS, and read-access geo-redundant storage, RA-GRS? Option A. GRS replicates data synchronously, while RA-GRS replicates asynchronously. Option B. RA-GRS provides a separate read-only endpoint for the secondary region, which GRS does not. Option C. GRS stores more copies of data than RA-GRS. Option D. RA-GRS offers automatic failover, whereas GRS requires manual failover. The correct answer is RA-GRS provides a separate, read-only endpoint for the secondary region, which GRS does not. Here's the explanation. Both GRS and RA-GRS replicate data using LRS in the primary and asynchronously to LRS in a secondary region. The critical distinction is that RA-GRS provides a separate read-only endpoint for the secondary region, allowing applications to read from it even when the primary is operational, enhancing read availability. GRS secondary data is not directly readable until a failover occurs. Question 8. A company requires a storage solution for mission-critical data that must survive an entire regional outage, with an acceptable recovery point objective, RPO, that allows for some minimal data loss during a disaster. Which redundancy option should they choose? Option A. Locally redundant storage, LRS. Option B. Zone redundant storage, ZRS. Option C. Geo-redundant storage, GRS. Option D. Standard performance storage with hot access tier. The correct answer is geo-redundant storage, GRS. Here's the explanation. GRS provides protection against entire regional disasters by asynchronously replicating data to a geographically distant secondary region, while LRS and ZRS protect against local or zonal failures. Only GRS and RA-GRS offer cross-region disaster recovery, accepting a non-zero RPO due to asynchronous replication. Question 9. When configuring geo-redundant storage, GRS, or read-access geo-redundant storage, RA-GRS, what type of replication is used for data transfer between the primary and secondary regions? Option A. Synchronous replication, ensuring zero data loss. Option B. Asynchronous replication, potentially leading to a non-zero recovery point objective, RPO. Option C. Batch replication, occurring once every 24 hours. Option D. Real-time, continuous replication with strong consistency across regions. The correct answer is asynchronous replication, potentially leading to a non-zero recovery point objective, RPO. Here's the explanation. For GRS and RA-GRS, data is synchronously replicated within the primary region, LRS, but then asynchronously replicated to the secondary region. Asynchronous replication means there's a slight delay, implying that in a disaster scenario, some data written just before the primary region failed might not have been replicated to the secondary, resulting in a non-zero RPO. Thanks for watching. Please subscribe to my channel.